Hello students, welcome to the video on Complementary Symmetry Class B Power Amplifier. We know the Complementary Symmetry Class B Power Amplifier also consists of two transistors, but the two transistors are different transistors. Okay, yes, the two transistors are different. Means if one is NPN, another one is PNP. In the case of push-pull, both are same. Okay, so now we'll move to the circuit diagram. Yes, it consists of two transistors. This is a circuit of class B complementary symmetry. The first transistor is NPN type. This is NPN and this is PNP. Now if you compare this circuit with class B push-pull, yes, class B push-pull consists of two transformers. One is the driver transformer, another one is the output transformer. Driver transformer is at the input side to drive the circuit and output transformer is to take the output. But this complementary symmetry is not having any transformers. So it is very simple, having lightweight. But the disadvantage of complementary symmetry is it won't have any impedance matching concept. With the transformer, we can do impedance matching very easily by varying the number of turns of the secondary. If the number of turns of the secondary varies, automatically the resistance varies, so that you can match that with the impedance of the loudspeaker, means the load. But here there is no transformer, that is the reason you won't get any impedance matching between the output and the load. Okay, so that is a disadvantage, but now I'll explain how it works. So now see, whenever you apply Vs, let us suppose Vs is like this. Yes, it goes to both transistors. For the positive half cycle, yes, assume that there is a positive half cycle, and here also positive half cycle. So what happens when the input signal is positive half cycle? As Q1 is NPN, its base is P type. So for the P type, if you apply a positive half cycle, then Q1 becomes on. Then say this is PNP, means the base. I'll indicate the emit terminals. Yes, here as Q2 base is N type. For the N type, if you apply a positive half cycle as input, then PNP transistor becomes off. So now this transistor gets disconnected, means it gets opened. So your circuit consists of only this transistor, and the output current and the emitted current will flow like this. That is nothing but your load current. So at V0, as V0, you are going to see this signal. Because what is the shape of IL? Yes, IL shape is nothing but input shape. Okay, so your IL is in the form of positive half cycle. So your output is also in the form of positive half cycle. Another important point. Yes, you are taking output from emitter means what configuration it is? It is the common collector configuration. We are not using any transformer for impedance matching, but to do at least a small impedance matching, here common collector configuration is used. Now coming to the negative half cycle. Suppose if the negative half cycle comes to the base of the Q1, and here also the negative half cycle. Q1 is NPN transistor, base is P-type. So for this negative half cycle, Q1 becomes off. Q2 is PNP and base is N-type. So for this negative half cycle, Q2 is on. Now this Q1 transistor gets disconnected. So your circuit consists of only Q2. And now see the emitter current. See the emitter current. This is the emitter current. This is the output current. So now what is the shape of it? The shape is nothing but its applied input. What is the input? This negative half cycle. So what is the shape of IL? Negative half cycle. So V0 is also negative half cycle. So for this full input signal, we are going to get full cycle as output. Remember this in class B, Q point is on x-axis. Okay, so if you use only one transistor, you will get only one half cycle as output. As you are using two transistors, you are going to get two cycles as output. Even you can check for the next half cycle. See this half cycle. So again, what will happen for this positive half cycle? Q1 on, Q2 off. So as Q1 is on, what about its output current? It is in the shape of this positive half cycle. So V0 is also in the shape of positive half cycle. For the next negative half cycle, what will happen? Q1 becomes off and Q2 becomes on. So now your emitter current is in the form of negative half cycle. Okay. So this is about the complementary symmetry. Its efficiency is same as that of class B push-pull. Means its efficiency is, maximum efficiency is 78.5%. Here the operation is same. For the full input signal, we are getting full cycle output. The input signal and output signal are same as that of class B push-pull, and we are calculating the efficiency for the output. So the efficiency is same and the power dissipation is same and the maximum power dissipated is also same. Okay, so that is about complementary symmetry class B power amplifier. Even harmonic distortion is also same. Okay, complementary symmetry power amplifier. Thank you very much.